Welcome. In this video, I'm going to demonstrate how to identify all the critical numbers of this function f of x. The first thing you want to do is find the first derivative, so f prime of x, and we're going to use the quotient rule here, that is x minus 1 prime times x squared minus x plus 1. And then from that, you subtract x minus 1 times x squared minus x plus 1 prime. And then, of course, in the denominator, we have x squared minus x plus 1 quantity squared. So f prime of x is equal to, well, this derivative is just 1 minus 0, so just 1. In that case, 1 times all of this is just all of this. That is x squared minus x plus 1 minus x minus 1 times 2x minus 1. And in my denominator, x squared minus x plus 1 quantity squared. Now this just needs to be simplified algebraically, so please pause your video and try to simplify this algebraically independently. All right, you should have paused your video and simplified from here to get negative x squared plus 2x, excuse me, not minus, plus 2x divided by x squared minus x plus 1 quantity squared. So of course we're going to look for two things. The first is, where does this first derivative f prime of x equals 0? And the second thing is, where is our first derivative f prime of x undefined? So now when we look at a quotient, so a rational function, and we want to see where it's equal to 0, as we do in this case, so that's negative x squared plus 2x divided by x squared minus x plus 1 quantity squared, we really only need to look at the numerator, because our first step here is going to be to multiply both sides by the denominator. And as you can see, if we multiply on the left by the denominator, that's 1. And on the right, 0 times anything is 0, so we'll end up with just negative x squared plus 2x equals 0. So I would suggest to save yourself the time and just set these up so that you're looking at the numerator equal to 0. So now let's factor negative x out of both terms, leaving us with x minus 2 equals 0. So x equals 0 is one critical number. The other critical number is found with x minus 2 equals 0, so x equals 2. Those are two critical numbers. Now let's look at where this function is undefined. And now when you're looking at where something is undefined, we want to look at two things. We want to see, is there a negative in an even root? So this could be 2, 4, 6, 8, and so on, the index of this. Or is there anything in the denominator here that is equal to 0? Because that would give us undefined if whatever we have in the denominator is equal to 0, or if there's a negative inside of an even root. There are no radicals, so we just need to look at this x squared minus x plus 1 quantity squared. Will that ever equal 0? Really, this is equivalent to looking at where x squared minus x plus 1 equals 0. And we can look at the quadratic formula here. So for the quadratic formula, a equals 1, b equals negative 1, c equals 1. And of course, remember, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Really quickly, though, we don't have to actually do all of this work. We can just look at what is inside this radical here called the discriminant. Now, there are three possibilities. B squared minus 4ac could be larger than 0. In that case, we have two roots. It could equal 0. In that case, we have one root, or it could be less than 0, in which case we have no roots, that is, no x-intercepts. And I'm going to make some space so I can just write this in here to the side. Okay, so here it is as an aside in case you don't remember. Let's recall the discriminant, and that's this part of the quadratic formula, what's in the square root. If it's greater than 0, we have 2 real roots. If it equals 0, we have 1 real root. If it's less than 0, we have no real roots. Okay, so I have my coefficients, a equals 1, b equals -1, c equals 1. That tells me that b squared minus 4ac is equal to -1 squared minus 4 times 1 times 1. So that's 1 minus 4 is -3. So -3 is less than 0. We are in this case, which means we have no real roots. That tells me that this function, our derivative here, is always defined. So this provides us with no additional critical numbers. Okay, finally we can write out our conclusion. Our only critical values of f of x are x equals 0 and x equals 2.